We're talking about the fundamental theorem of algebra. And so the first thing we have to do is introduce the fundamental theorem of algebra, and that is every polynomial function of degree n is greater than or equal to 1 has at least one zero, where a zero may be a complex number. The corollary to that is every polynomial function of degree n is greater than or equal to 1 has exactly n zeros, including multiplicities. And so what that means is the highest degree of the polynomial, that's how many zeros we should expect. And we have some examples that we can look at. Right here we have 2x minus 4. That is a linear function with degree 1, so we would expect that it would have 1, 0. And if we look at that right here, we do have 1, 0 at 2, 0. It crosses the x-axis once and only once, so it only has 1, 0. Now we have a quadratic function, x squared minus 2x minus 3, and we would expect that this function would have 2 zeros, and we see that it does. It has 2 zeros. It has one at negative 1, 0, and then it has one at 3, 0. Crosses it twice. We'll shut that one off for right now. And now we have another function, polynomial, and this one has highest degree of 4, so we can turn that on, and then we see that it does have 4 zeros. It has 1 here, we have 1 at the 0, 2, 3, 4. So it has 4 zeros where it crosses 4 times. But now just because it has a degree 4 doesn't mean it has 4 independent real solutions. If we change this function a little bit, this is still degree 4, but now we only have 1, 2, 3 real solutions. So in this case, this means one of these has to be a double root. And in this case, we remember that if the graph comes down and touches the x-axis but does not cross it, we know that we have a double root or a multiplicity of 2 there. So those are some examples that we can look at, and now we can look at what does that mean if we can just see to kind of what are we going to expect going forward. So this one says, we have a couple examples. Identify the number of solutions of zeros. So we look at this, we have a term that has a degree 6, a degree 3, and a degree 1. So the degree is 6. And what does that mean? We should expect that there are 6 zeros. Now we have another polynomial over here. This one's written a little bit out of order. So we have degree 1, degree 3, degree 8, degree 5, and then we have a constant term. So we're looking at here, and obviously we see our degree is 8. So we would expect that there are 8 zeros.